Clap along if you feel like a room without a roof. Hey! Clap along if you feel like happiness is the truth. Hey! Clap along if you feel like a. I don't know what the next line is. Hey, class, welcome to Unit 10. New unit here where we're going to be looking at right triangles. And we're going to begin by looking at the Pythagorean Theorem. We're going to talk about what is the Pythagorean Theorem and how can it be applied. So, in a right triangle, the Pythagorean theorem says the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. Well, what does all that mean? Here we have a right triangle, and one of the ways that we know that we have a right triangle is that we have a right angle. And as I'm recording this, the announcements are coming on, which is not good. One of the things that we want to recognize in a right triangle is that we have a right angle. And right angles, remember, are 90 degrees. So as we're looking here, we want to recognize where that right angle is. And then the first part is we have to identify the hypotenuse. Now, if you go to your right angle and you draw an arrow to the opposite side, that will give you the hypotenuse. And then our other two sides are called legs. So we have a leg and we have a leg. So what the Pythagorean theorem says is that the hypotenuse squared equals the sum of the squares of the legs. And you want to learn that vocabulary. Later on, if you have a math teacher, they're not looking to hear c squared equals a squared plus b squared, or a squared plus b squared equals c squared, although we often do use that to represent the Pythagorean theorem. Remember, c is the hypotenuse and a and b are the legs. So it's a little more technically correct to say the hypotenuse squared equals the sum of the squares of the legs. Remember, the word sum means to add. So as we look at this, find the length of the third side, we want to begin by drawing a right triangle. And here's our right triangle. And we have A is 3, B is 4, and let's call our third side C. Now, again, the first thing that you want to do is identify your hypotenuse. So C is going to be the hypotenuse. And we have here a leg and here another leg. So our formula is the hypotenuse squared equals the sum of the squares of the legs. So we substitute in here, we say, okay, well, c squared equals 3 squared plus 4 squared. And when you do that 3 and 4, the order doesn't matter. So therefore, c squared, 3 times 3 is 9, plus 4 times 4 is 16. C squared equals 25. And when we take the square root of 25 is 5. Don't put a radical on that. So that is a 3, 4, 5. Now we have number 2. Again, we have a right triangle. So we're going to draw a picture, the right angle. This time, however, we know 10, that's the long side. This is 6, and let's call that A. And here again, let's just kind of go through our progression. We're looking at our hypotenuse. What are the other two sides called? That's right, they're legs. So we have a leg and a leg. And so the hypotenuse squared equals the leg squared plus the leg squared. the sum of the squares of the legs. So I'm going to substitute in here. This time my hypotenuse is 10. I have 6 squared plus a squared. And so 10 squared is 100. 6 squared is 36 plus a squared. So we're going to solve this using inverse operations. We're going to subtract 36 from both sides. Gives us 64 equals a squared. We're going to take the square root of that, and the square root of 64 is 8. So the side of our triangle is 8. So those, it looks a little bit different. In number 1, we were looking for the hypotenuse. In number 2, we were looking for a leg. So pay attention to what are you looking for, because the process is a little different if you're looking for the hypotenuse, like number 1, or if you're looking for a leg, like number 2. Now, we add into this in here the phrase in simplest radical form and to the nearest hundredth. So as we do this, we're going to want to have a calculator at hand. So here again, as we look here at the first example, I'm going to draw a picture. And when I draw this picture, I notice A and B, which are the legs, are both 3 and 3. That's going to be an isosceles triangle, but I don't know C. So here again, it's the hypotenuse squared equals the sum of the squares of the legs. So we want to start off by identifying our hypotenuse. So from the right angle, draw your arrow over to that side. There it is, C. So as we substitute this in, we're going to have C squared equals 3 squared plus 3 squared. So C squared equals 9 plus 9. C squared equals 18. Now, when we go to take the square root of 18, which is the next thing that we have to do, we get C equals radical 18. 18 is not a perfect square. So we got to review here, how do we simplify those square roots? Well, we write out our list of perfect squares. 1, 4, 9, 16, 25. I'm going to stop there because I have gone past 18. And now I'm going to check, does 16 go into 18? No. Does 9 go into 18? Yes. So 9 goes into, it's called the largest perfect square factor. 9 times what? 9 times 2. Now, in the next phase, we put the square root of 9, which is 3 radical 2. So that's what we call simplest radical form. Where it said the other part, which said round it to the nearest hundredth, now we're going to put that in our calculator, and I'm just going to push pause to go get myself a calculator. Okay, I'm back with my calculator. It's in my hand. You're not going to see it here on here. But what I'm just doing is entering in 3 square root of 2. And we come up with an answer of 4.2426. Now, we want to round to the nearest hundredth, which is the second decimal place. So I look at that 2 there. That's 4 or less, so therefore we're just going to drop it. So C is approximately 4.24. Okay. So either way. Now you put those little wavy equal sign thing as a wave. That means approximately. So when you see that, sometimes when we're rounding, we'll write it in that way. All right, let's I'm going to skip number 4, and I'm just going to jump right to number 5. And here again, we have a right triangle, so that's the setup that we have. So here's my right triangle. In this one, I've got a leg, which is the square root of 3. I've got C, which is our hypotenuse, which is the square root of 14. Let's call this other one that we're looking for A. So here's my right angle. Well, let's work through our progression. We start, we want to find, hey, what is the hypotenuse? This side over here, hypotenuse. Okay, that means our other two sides are going to be legs. I got a leg here, I got a leg here. And I think we've done it enough at this point where we don't need to write the formula out, but we take and we put in parentheses the square root of 14 squared equals the square root of 3 squared plus a squared. Now, when you are squaring a square root, like we're doing here in this, what happens is the squared cancels out the square root. So this really becomes just 14. You could enter that into your calculator, it would give you that value, but that's kind of a shortcut to recognize. So following that same reasoning, the first one here is now going to be 3 plus a squared. So I subtract 3, and I get 11 equals a squared. Take the square root of that. The square root of 11 equals a. Can we simplify that? Well, let's look at our perfect squares. Will 9 go into 11? No. Will 4 go into 11? No. Will 1? No. So there it is in simplest radical form. Rounded to the nearest 100th becomes 3.3166. Okay, now again, where are we looking to round it to? The 100th one right there. So we look to the right of it. What do we find? A number 5 or greater. So we're going to round up. 3.32 is approximately A. And that's rounding to the nearest 100th. All right. Couple more that give you a little bit more of the complexity that we have here in this. If we look at number 6, we have a picture drawn. Start at our right angle. Identify your hypotenuse. Identify your two legs. So I'm just going to write it again this time. The hypotenuse squared equals the sum of the squares of the legs. Hopefully that's getting into your understanding. So we have 8 squared equals x squared plus x squared. So 8 squared is 64 equals x squared plus x squared. Well, the question becomes, can we combine those together? Can we add like terms? Well, they both have an x and they're both raised to the second power. Now we want to remember there's a kind of invisible coefficient of 1 in front of those. So when we add those together, we get 64 equals 2x squared. So now as we're solving that, what's going to happen? Well, we're going to divide by 2. 64 divided by 2 is 32 equals x squared. All right, again, we want to put this in simplest radical form. So we take the square root. Is 32 a perfect square? The answer is no, it's not. So I'm going to make 2 radicals. Okay, I'm going to rewrite my list of perfect squares. 1, 4, 9, 16, 25, 36. Okay, I can stop now. Will 25 go into 32? No. Will 16 go into 32? Oh, yes it does. It goes in 2 times. Now, what is the square root of 16? That's 4. Make sure you don't put a radical with there. Just 4 times the square root of 2. And that is the other side. So we're getting into a little bit more complexity with some of those questions. All right, let's look at number 7 now. That's going to add even another layer of it. Start at your right angle. Draw it over. Here's your hypotenuse. The other two sides are your legs. Add a little variety with this color. So we have the square root of 200 squared equals 3x squared plus 4x squared. Now it's important that you put that in parentheses, and we're going to see why here in a minute. As we look at the first one, we remember square root squared, those two just cancel each other out, and this is just 200. Now, when we are over here, 3x squared, let's remember, what does it mean to square something? Multiply it by itself. So 3x times 3x. 3 times 3 is 9. X times x is x squared. So that's 9x squared. A lot of times the mistake students make there is they only write that as 3x squared. And then in the next one, 4x times 4x. 4 times 4 is 16. X times x is x squared. So we have 200 equals, can we combine those? Are they like terms? Yes, they are. 25x squared. We divide by 25. Okay, 200 divided by 25 is going to be 8 equals x squared. Let's take the square root. Is 8 a perfect square? No, it's not. 1, 4, 9. I'm going to stop right there. 2 radicals. Will 9 go into it? Obviously not. It's larger. Will 4 go into it? Yes, it will. 2 times. The square root of 4 is 2. Radical 2 doesn't have, it's not a perfect square, so it stays. Okay? So just a little bit more involved with some of the numbers that we have. Okay, moving on. Now, the question becomes, is the triangle a right triangle? Well, here's what we're looking for. In a right triangle, we know that the hypotenuse squared equals the sum of the squares of the legs. I know I sound like a broken record, but I want you to understand that. Now, here's the key. Which of those sides is going to be the hypotenuse? It's got to be the longest one. All right? In this question, it's a question mark for us. We don't know if they're equal. So we try it out. Well, is 4 squared, is that equal to 2 squared plus 3 squared? The 4 squared is 16. The question is, does 16 equal 4 plus 9? 16 does not equal 13, and therefore it is not a right triangle. If it was equal, they would be a right triangle. But in this case, it's not. What I'd like you to do is push pause on your video and try the next two. Are those going to be a right triangle? And we'll come back in a minute and check those answers out. Okay, welcome back. And here we are. We've got the work. You can check your answers here. Number 9, yes, it is a right triangle. Number 10, no, it's not. Remember, you have to compare the longest side. So 25 and 12, those are the longest sides. That's what we're looking at to compare. All right, now, what I'd like to do here is number 11 and 12. These are two common types of questions that we can see. If the length of a rectangle is 24 centimeters and the width is 7 centimeters, find the length of the diagonal. So we're trying to find the diagonal. Well, let's draw a rectangle first here to get us started. And wrong tool for that. Hang on. Okay. Here's our rectangle tool. All right, and we have a diagonal. Now, a diagonal goes to a non-adjacent vertice is the way that we say that in math terms, which means you can't go to the one next to it. It's not the side. So the length is Get my pen back. Whoa, that's not the pen. Excuse me on there. The length is 24 centimeters, and our width is 7 centimeters. And we're going to try and find the diagonal. One of the things that we know about a rectangle is that they have right angles. So what we found here is that this figure creates a right triangle. So there it is. And the diagonal that we're looking for is the hypotenuse of that triangle. So again, remember, at your right angle, draw it over. There's your hypotenuse, and let's call it x in this case. So what do we know? The hypotenuse squared equals the sum of the squares of the legs. So in this instance, our hypotenuse is x, and our legs are 7 and 24. So we have x squared equals, now 7 squared is 49, and 24 squared is 576. So when we add those two together, we get 625. Some of you might notice the same numbers from before. And I want to check that one on my calculator. Is that a perfect square? Okay, yes, that is. So it's going to be 25 centimeters for the length of our diagonal. All right. So draw a picture and make sure we're labeling first. Really want to identify the difference between the hypotenuse and the leg. All right, this will be the last one that we look at, and it is a ladder is placed 5 feet from the foot of a wall. The top of the ladder reaches a point 12 feet above the ground. Find the length of the ladder. All right, so here's our wall. It's going to be a vertical line, and you're going to have a ladder that leans against that wall, and that ladder is going to intersect the ground. So we want to be able to draw a picture that represents that. Now, one of the things that we are doing in this is we're going to assume that the wall forms a right angle with the ground. Okay. So we have a right angle there, therefore we have a right triangle. The top of the ladder reaches a point 12 feet above the ground. So that's looking at this distance. The ladder is 12 feet high, so you go from the ground up to 12 feet and is 5 feet from the base of the building. We want to find the length of the ladder. Again, let's call that x. So here it is. We see, what do we have? We have a right triangle. When we're talking about right triangles, when we know two sides, we want to find the third side, start by identifying the hypotenuse. There's our hypotenuse, x. So x squared is going to equal 5 squared plus 12 squared. So x squared equals 25 plus 144. 25 plus 144 is 169. As we take the square root of 169, is that a perfect square? Yes, it is. So 13 feet, all right? And it's, no specific rounding there, so we're good as we have it. All right, so that's the beginning of the Pythagorean theorem. And it's really important, again, that we're understanding where the hypotenuse is in those things. And if you need to go back and look, feel free to go back and look these over. And we'll get ready for the practice ones we're going to work on in class.